There's two more sections in Chapter 8. Today we're going to be focusing on some negative numbers, specifically talking about powers and roots. So we're going to have exponents with negatives as the base, and we're going to be doing different roots with negatives. So the question for today, how do negative numbers actually affect nth roots and various powers? For our first example, we're just going to simplify this by hand, trying to figure out exactly what's going on here as we increase the exponent amount, the powers, by 1. We're going to start with negative 3 to the first power. That's pretty simple because negative 3 to the first just means you have one of them. So this would be the same thing as saying negative 3. Then we go to the next one. What does negative 3 to the second power mean? That means you have a negative 3 times another negative 3, right? And that's the same thing as having two negatives being multiplied together gives you 9. Okay, and the next one, we're going to do it 3 times. So we have 1, 2, 3. 3 negatives. So multiply the first two together, we get a positive 9. Multiply by the next one, you get a negative 3 times 9, which gives you a negative 27. I'm just going to circle my answers as we go. And we'll go up to the fourth power. So this means we'd have 4 of them being multiplied together. So we have 1, 2, 3, 4. So what do we get here when we multiply these two? Negative 3 times negative 3, positive 9. And then if we did these two, that would also give you a 9. 9 times 9 gives you positive 81. So here's kind of the pattern we have. We have negative 3, and then we go up to the next power, we get 9. And then the next power, we get negative 27. And then the fourth power, we're at 81, right? So this is how it's going. We're going to the first power, second power, third, fourth, and we can keep going, right? Fifth. And the whole point of doing this one, especially with these negative numbers, is to kind of show the pattern of how negatives operate when you change powers and go to the next one. So we're going to kind of make a conclusion here about what's going on. So our first number, when we use the first power, we got a negative number, right? Negative. When we went to the second power, squared, we got positive. We went to the third power, we got a negative. Fourth power is positive. Any guesses as what to be the fifth power? Of course, it's going to be a negative. And this pattern is going to continue back and forth, back and forth. So we're just going to summarize what happens. So when do you get negative answers? When is that? Specifically when the power is odd, right? And every time you get a positive answer, that's every time you have an even power. So we're going to go down to the box on the next page, actually. And we're going to fill in this little table. Well, anytime you have a negative base, that's what this is about. It's only about negative bases. If you have a power exponent, this is like what we just did, like an example, negative 3 to some power. Anytime we use an odd power, like 1, 3, 5, 7, so on, what did we say it was? If I go back, odd powers give you negative answers. And then what if it was an even power, like 2, 4, 6, ... Evens, which we only saw 2 of them, but we know if we would keep going, we would get more. Every single time, those were positive. Positive answers. So it's something to note here whenever we do powers, whether they're odd or even, it's a good thing to recognize whether you're going to get a negative number out or a positive number. Now we're going to do the same thing, but we're going to talk about roots, so change the different roots. So we'll start with square roots. We're going to take the square root of 16. Now some of these will be on the table too, so you can keep using it. the square root of 16 is 4. Okay? Now watch the pattern as we go here. What happens when we put a negative number in there? What's the square root of negative 16? It's not negative 4. If you remember from a long time ago, the negative inside the square root's not good. It gives you an I. This is 4I. Okay, let's go to the next root. Third root of 8. It's on your table. That's number 8, or not 8. That's the number 2. But if you put a negative in there, which you could probably do it in your calculator if you want to, the difference being, what number times itself 3 times gives you negative 8? This is going to be a negative 2. Right? Just think about the fact that if you had 3 of these being multiplied together, negative 2 times negative 2 times negative 2, that does give you negative 8, and you can check it yourself. Okay, let's jump to the fourth root. Fourth root of 81, again on the table, you can check it yourself. That is the number 3. And the fourth root, whoops, this is supposed to say fourth. The fourth root of negative 81 would be, guess what? We've seen this before. You can put in the calculator and see. You're not going to get a good answer because it's 3I. And then the last set, maybe you can see the pattern that's going on here. We are going to do the fifth root of 32. So that is the number 2. And then when we do the fifth root of negative 32, that's actually going to be okay. You're going to get negative 2. So what's going on here? Well, if we don't look at the positive ones, right? If you look at all the positive ones, like 16, 8, 81, and 32, they all come out to be positive answers. So if we kind of just don't look at these for a moment, all the positive ones, what are we getting here when we look at the negatives? If you have a square root, which is a 2, you get out an I. If you use a fourth root, 4, you also get out an I. What if we change it to a 3, third root? You get out a negative answer. Fifth root, you get out a negative answer. So this is kind of the pattern that we're seeing. Again, with the odds and evens. If you have an even power, even root, I guess, it's even root, every time you're going to get out imaginary. Over here, if you have an odd root, you get out negative numbers, right? So let's go ahead and fill in our table. Now when we're talking about roots, if we have an odd root, if you don't need to go back, you can look at it. Odd roots, 3 and 5, we got a negative number, negative answer. But if we get an even root, right, even root, look at that chart. These came out to be imaginary. These are non-real. Imaginary. And they're positive, right? Positive imaginaries over here, 3 and 4. Because the negative sign kind of takes up the imaginary. Imaginary / positive answers. So anytime we do problems like this, you might want to go back and look at this table or kind of understand what you're going to get. The good thing is no matter when you have an odd power or an odd root, it doesn't matter. With negatives, you're always going to get a negative answer. The only difference is whenever you have evens, you have to worry about, well, is it a power or is it a root? Okay, before we move too far on, we're going to stop here for a moment and just talk about the significance of parentheses. So for example, we're going to do one with a parenthesis, one without a parenthesis, so you know what's going on here. This is also why many people get things wrong in the calculator whenever they forget to type things like with parentheses in it. The meaning of this without parentheses just means that the 2 here is being raised to the 4th power. So this negative sign just kind of sits there, and this means you have 4 2's being multiplied together. 1, 2, 3, 4. Very different than what's going on over here. right? So whenever you put these together, you would have a negative times a positive, which would be negative 4. Positive times a positive, that'd be positive 4. And you multiply those two together, you get negative 16. So what really happens is you have this negative sign sitting out here, and it kind of just gets carried down the whole way through. Difference being over here, when you have a negative 2 in parentheses, which is what we've been doing throughout this lesson, that means you actually have 4 negative 2's being multiplied together. Which is why when we use the table, when we're talking about if you have negative even, you're going to get a positive number. So it's positive 4 times positive 4, which is 16. Just be very careful with this distinct difference. Parentheses are very important. Example 4, write without exponents this here. We have negative 4 to the 5th times negative 4 to the negative 3rd. If you remember, when you have the same base, which we do, we're allowed to add exponents, right? It's just add. So I'm going to go ahead and keep the base the same. Well, a lot of people like to change the base, but you don't change the base. And we just add them. 5 plus negative 3. Right? This is what you're doing off the side, right? And that answer is positive 2. And so we're writing this without exponents, so we put them together. And this means we have negative 4 squared, which means you have negative 4 times negative 4. And if you even look at your little table here, powers that are even are going to give you a positive answer. So we're going to get positive 16. We have one more left, one more example to go through, but I think I might also do some of the huddle problems. So that way you know how to do some other problems rather than just one that's here. All right, nth root of a product theorem, which I think we've had this before. When nth root of x and nth root of y are defined and are real numbers, then the nth root of x times y is also defined. And if you remember, we can split these apart. The nth root of x times the nth root of y. So we're going to keep applying this. We've seen this multiple times before where we split them up or put them back together. They mean the same thing, and we've done it before. So we're going to try it again with some negatives. So we're going to simplify the 5th root of negative 640 x to the 8th. If you remember, we used to try to find the number in here on the table, looking down the 5th column, right? 1, 32, so on, dot, dot, dot. So what you're going to do is figure out what goes into 640. Don't worry about the negative sign. It's kind of the same thing we've been doing before. And I believe it actually is going to be 32. So I'm going to break this into 32 times 20. Yeah, I think so. 32 times 20 is what it is. I just divided that one real quick by 32. So what I'm going to do here is in order to deal with the negative sign, we're going to break this apart. We're going to say it's the 5th root of 32 times the 5th root of 20. And we can also leave the x to the 8th in there. Okay, and then we know how to do the 5th root of 32. Oops, sorry, it's a negative. Put the negative on the 32. Messed up there. And if you remember from the table, if you need to go back, the 5th root of a negative number, right, this is an odd. So what's odd roots? Root, odd, we're going to get a negative answer. So we do not get imaginary numbers here, which is good. And so you take the 5th root of negative 32, you get a negative answer. You can use your table. Should give you the answer of 2, but there's a negative there, so we know we're going to get negative 2. And then we have the 5th root of 20 x to the 8th. And we're not really done because we haven't talked about the variable x. So we can actually ask ourselves, okay, well, how many times does 5 go into 8? That is 1 time. So we are going to get an x out of this. So this will be negative, I'll put it up here, negative 2x. So 1 comes out. And think about how many are left over. 5th root of 20 x to the, well, if we took out a 5 instead of 5, there's going to be 4 left. And that would be your answer. So now we're going to watch when we have negatives inside here, whether we're going to get just a negative answer or you might get imaginary. Just depends, right? Those are the two options back here. With roots, you're going to get negative answers or imaginaries. Okay, let's maybe do some huddle. go through these real quick. Tell whether the following will be positive or negative, then simplify. So if I'm just going to go through and talk about whether they're positive or negative, and then you guys can simplify. Remember, if you have a negative number that's raised to an even power, just keep going back to this table. Power exponent, even, we know it's going to be positive. So I'm just going to label these as positive. This one might trip you up because there's no parentheses. So 4 to the 4th will be positive, but this negative sign is going to stay there. So we know this is going to be negative. Ooh, what does this do? What happens when you have a negative exponent? Remember, we talked about this just recently. You can put this on the bottom. So really, you would write this like this. 1 over negative 9 to the positive 3. Now we can talk about whether it's odd or even. So odd powers with a negative number. We just talked about that over here. We're going to get a positive answer. And you guys can figure that out. It'd be 1 over, multiply negative 9 3 times. Oh, sorry. This one was even. That was positive. This is odd. It's going to be negative. Whoops. Negative. And the last one, kind of the same idea. You just don't have it as a fraction. It's still odd. Answer is going to be negative. But you have to finish them up. How about something like 3? Calculate the square root of negative 4 times the square root of negative 9. If you remember, we used to do these before when we had talked about imaginary numbers, because this will give you imaginary because you have even roots. So we go back to the table. Even roots down here, right, where these intersect, going this way and going this way. That means they're imaginary. Okay. Oh, that's right. So this means we're going to get imaginary. So I, square root of 4 is 2, times square root of negative 9 is 3i. And then you could multiply them together. You'd get 6i squared. Don't forget what I squared is from a long time ago. What is I squared? That's equal to negative 1. This answer is negative 6. So individually, these give you i's, but when you put these i's together, it changes it quite a bit. How about number 3 in the multiple choice? Determine which of the following best describes the expression. Either going to say it's real and positive, real negative, or non-real. In other words, imaginary. So the third root of a negative number, third root, that's odd root. Keep going back to this table. So far back now. An odd root is going to be a negative answer. So this is going to be B. Square root of 12. Well, this one's not too bad because this is a positive number. We haven't really talked about when it's positive. So if this is a positive number and you square root it, that's also going to be positive. Real positive. Same thing down here. Not to mess with you, but if you have a positive number in here, we've only talked about negatives today. So doing a fourth root of a positive is still going to be positive. The 11th root of negative 9, that's odd. So go back to this. All odds are going to be negative. The 6th root, well, that's even of a negative. That's going to be imaginary. And lastly, we have the square root, which is a 2. That's even, is also imaginary. Okay, let's see what else I want to do. I'm going to jump down to number 4, part E. I want to do like maybe 1 or 2 more, then we'll finish this up. If we do the 5th root of negative, so this one has a plus sign between it. You would think that maybe you could put them together, but a couple reasons why. You can't actually add things together that have roots until you actually simplify them. And this has a 5, that has a 4. You have to do them separately. So we will. The 5th root of negative 32, if you remember, this is odd. That's going to give us just a negative number. And the 5th root of 32, just pretend the negative's not there, is number 2. Then we ask ourselves, how many times does 5 go into 10? That would be 2. So we get p squared out of this. And there's no p's left over. So we actually use this entire thing, used up the root, there's nothing left. Plus, do the same thing over here. This doesn't have a negative number, so we should be fine to use the table here. 4 through to 16 is the number 2, I believe. And then how many times does 4 go into 16? 4, 8, 12, 16, that'd be 4. And the question is, can we put these two things together if they have different powers? No, you can't. That's your answer, unfortunately. You do the same thing with part F, which is the exact same problem without any variables. Let's see what else we got. Maybe something like E. Now, these ones you can put together as multiplication. You have the same root. So you can multiply these together. 49 times negative 21. That's 1,029. You're doing the third root. 1,029. Put the m's together. That means you add exponents. That's m to the 8th. Put the n's together, n to the 9th. And then we got to break apart 1,029. Going down the cubed column. I think. Yeah, it's going to be a bunch of 7s. So we have, I divided by 343, and the other number is 3. So we can break this apart. Oh, sorry, it was negative. Keep forgetting about the negative. So we'll do negative 343 times the cube root of 3, and then we have m8 n to the 9th. This part is in your table besides the negative part, which we know if we have an odd negative root, it's going to be negative. And that's the number, I believe, 7 times the cube root of 3 m to the 8 n to the 9th. Of course, at this point, you could probably just go through and figure out how many m's and n's come out. I'll do that to my next step. So we have negative 7. How many m's come out? 3 goes into 8 2 times. And there'll still be 1 left over because you get to, oh no, you still be 2 left over. 3 goes into 9 3 times. And no n's. So that's gone. There's going to be 2 left of these, though. So we have the cube root of 3m squared. There you go. Those ones are just a little bit harder to do. Let's do another one. If we have, how about part D? The cube root of negative 27 and the cube root of 64, they're both in the table, so I wouldn't put these two together. I would just do them separately. The cube root of negative 27, we know we're going to get a negative number. That would be negative 3 times, this will also give us a negative number. Cube root of 64, I believe, is 4. And then you multiply these two together. When you multiply two negatives together, you get a positive 12. I think I did enough examples to hopefully be able to finish the rest yourself. In this one, tell whether the number will be positive, negative, or imaginary without actually calculating it. Hopefully you can do that with the table. Yeah, I think the rest of them are not too bad. So finish the rest of that, and we will be done with 8.7.